Okay, so you're going to be asked to investigate how you think you could add and subtract polynomials. So putting two or more expressions together by adding or subtracting. How do you think you might do that? So I want you to think about this with a partner if you can, and try to work together to come up with a solution. And maybe pause the video and give it a try. And then when you think you've got an answer, say for the first one, restart the video, pause again, and so on. Okay, so hopefully you have now given the first one or maybe the first two a try. So if we're looking at the first one way to add polynomials, and you may have tried this, you may not have. Oh, let me just give my pen a second here to be working, is 3x plus 1 plus 4x minus 2. You might have set it up like an addition problem. We're just adding these. And then you have to think about collecting your like terms, right? You can't add 3x plus 1 together, but you can add a 3x plus 4x together. So we could get 7x, and you could add 1 plus negative 2 together and get minus 1. So that might be something that you and your partner came up with of, hey, let's turn this into just an addition problem and let's collect our like terms. And that's pretty much what adding polynomials is. It's just sort of saying, hey, what is 3x plus 1 plus 4x plus negative 2? And then put your like terms together. So if we look at this next one, and if you haven't tried it, pause and give it a try with your partner. Same idea. We're going to put this together. We're going to say, what's 5a plus 4 minus 3a squared plus negative a squared minus 7a plus 5. Now what you're going to notice with this one is, ooh, our like terms aren't really lined up, but it still works kind of the same way. What would negative 3a squared plus negative 1? Remember, that means negative 1. Let me just add that 1 there. Whoops, for some reason my plus sign became a minus, so let me change that. Okay, so what would negative 3a squared plus negative 1a squared be? And you're going to end up with negative 4a squared. And then what would 5a plus negative 7a be? Well, you're going to end up with negative 2a. And if you're having trouble with this, you might have to go back and review collecting like terms. Finally, what would 4 plus, oh, for some reason the 5 went away too. Here we go. What would 4 plus 5 be? That would be 9. And that is going to be your final answer. So again, all you're doing is you're just adding these two expressions together and collecting your like terms. So you can't add 5a plus 4 together, but you could add 5a plus negative 7a. So again, if you see that, here is your 5a plus negative 7a. And then you could do your 4 plus 5 and get an answer. And then finally, you could do your negative 3a squared plus negative 1a squared. Now, people often ask me, does the order matter? The answer is yes and no. So technically speaking, in math, we want to go from the highest power, so the thing that has the most exponents, all the way down to the constant. So that's why I've written them in the order of a squared, then a, then the constant. However, if you're writing them in a different order, but you have the signs correct, you'll still get marked correct for that. So don't stress out about that. But as you proceed in your mathematical career, you're going to want to pay attention to that order. Okay, so let's look at subtracting. If you haven't had a chance to try this yet, pause the video and give it a try with your partner. Okay, so hopefully you've maybe thought, hey, let's try a similar thing to what we just did. Let's set it up like a subtraction problem. 3x minus 6 minus negative x plus 2. Now, problem with this one is we are subtracting. And we have to be really careful because here we see a plus 2. Remember, when we subtract a positive 2, we have to be careful with what our answer will be. So technically, we are actually doing 3x minus negative x. 3x minus negative x. And we are technically doing, we'll just use a different color, negative 6 minus positive 2. You've got to be really, really careful with that. So technically speaking, 3x minus negative x actually becomes 4x. And negative 6 minus positive 2 is actually negative 8. So check to see if you got that. This one's a little bit tricky. Now, if you are kind of thinking in your head, hey, wait a minute, we just learned about subtracting integers. And when we subtracted integers, we added the opposite. So hey, couldn't I just turn this into an addition problem? And the answer is yes, you can. So you could, if you wanted to, think of this as 3a minus 2 plus 4a squared. And then you're going to change that subtraction. You're going to add the opposite. Well, the opposite would be negative 5a squared, positive 7a, and minus 5. You're going to add the opposite. And then you're going to do what you just did. You're going to put your like terms together. You're going to say, hey, I'm doing 4a squared plus negative 5a squared. And I'm doing 3a plus 7a. And I'm doing negative 2 plus negative 5. I'm going to collect those like terms, and I'm going to end up with negative a squared and 10a and negative 7. Be really careful with subtracting. When you subtract, you add the opposite. So let's look at this final example, which puts everything together. And if you haven't had a chance to try this, take a second, pause, and give it a try. So what I'm going to do is put together kind of what I've just learned. And I've just learned that anywhere I see a subtraction sign, I'm actually going to turn that into adding the opposite. So my first bracket is just 3x plus 2. So I'm just going to leave that as 3x plus 2. Here I'm going to add the opposite. So that means the signs will change. So it was positive 4x, now it's negative. It was negative 3, now it's positive. I add the opposite. This next one won't change because it has a plus sign. Then this last one, again, I'm going to add the opposite. Now, once I've done that, for all intents and purposes, adding, basically, I can just erase the brackets. That's really what I'm doing. I can just say, hey, I'm just going to ignore these brackets. I'm just going to write it as if the brackets weren't there, because the brackets don't really play a role when I'm adding. So I've now just gotten rid of the brackets. And now I can collect my like terms. I can put all my x's together. And I can put all my constants together. And then I can just use my knowledge of integers, 3x, take away 4x, take away 3x, plus 1. I can just say, hey, okay, 3x take away 4, that's negative 1. Negative 1 minus 3, that's negative 4. Negative 4 plus 1 is negative 3. And 2 plus 3 is 5. 5 minus 1 is 4. 4 minus 4 is 0. So I can actually just leave my answer as this. So that is how you add and subtract polynomials. When you're adding, just get rid of the brackets as if they weren't there and just collect like terms. So really adding polynomials is really just like collecting like terms. You just have brackets that you kind of ignore. Subtracting polynomials, you have to do one extra step. You have to add the opposite of whatever's in the bracket, and then you just get rid of the brackets and collect like terms. So really, once you get the hang of it, it's really exactly like collecting like terms.